This conference will now be recorded.
Hi team. Seems like today I'm seeing most of our. Shall we try it tomorrow? See that somebody else came. Yeah. You tell me the folks. Should we continue or should we try tomorrow? Because I see like 5 or 6 of our guys were missing. What's your? Can you hear me? Am I audible? Yeah. So what do you suggest? Your opinion matters to me now. Shall we continue or shall we try tomorrow? Because I see there's a less attendance today. I don't know. It might be Monday and all right, the project stuff. I don't know the reasons, but Madhu just called me and told he was okay. So okay, fine. We'll continue. Yeah. So let's continue. Today we'll start. We'll do with map thing. Let's have some idea about map. So on Saturday, right, we had a good session on that set thing, like we had a very good discussion about set, and we understood so many differences and the pros and cons, like difference between sequence and set, as well as also the difference between hash set and linked. I mean list set. Also the difference between tree set and bit set. We have seen everything in detail, each and every class implementation class. And we have also seen like a couple of use cases with those implementation classes, right? So let's continue. Okay, let me share the screen and let's move to the discussion part. And the hierarchy, right? You know about map hierarchy here. Anyhow, let me get it from the official doc. So probably we are finishing almost the complete hierarchy of this immutable collection. And once you know how immutable collection works, it's almost same for mutable. But the difference is we cannot modify immutable, but we can modify mutable. That is the difference. Other than that, the way we create objects, the way we apply those scenarios or use cases, those things are same. That doesn't change. Got it right? So hope that's clear for all of you. Next one after that. So let's see here now. So this is the map hierarchy. Today we are going to close this map probably if possible. Map is something, right, which is, you can see here, it is a child of iterable, and then it has different implementation classes, hash map, list map. These are direct descendants or direct implementation classes. Sort map is a trait. Whichever is in blue color here, if you see, they are all traits. Whichever is in black, they are all implementation classes. And these are direct implementation classes, hash map and list map. And sorted map is a trait. The tree map is an implementation class. And this is indirect descendant or indirect child of map. The point is, what is this map and why do we need map? That's we need to understand here. Okay? So let's have a quick idea. Okay. Hope you can see the screen, right? And this is what we had discussed in the yesterday's session. We have covered all the stuff. The list step, the list set, and the hash set, and then also we had discussed about the sorted set as well as the differences. Also, we have seen set this sequence versus set. This is still this we have discussed yesterday. So now, what we have to do? We have to start doing about map. So what is this map? When do we do? When do we need map? So map is something which is most used data structure in your big data. Many times we use this map collection, right? So, and why it is so popular? This reason is so simple. Map is used to store data in the form of a key and value keys. When do we need a map? A map is used. When do we need it? To store data in the form of a key and value keys. That is one thing. Next one. Now, when you talk about the properties, I told you even on Saturday or sometime in many other sessions. Map and set have similar features, right? Like set, map doesn't allow duplicate keys, okay? And also insertion order is not preserved. So there are a couple of features we need to add. These are generalized features. Again, when we go to the class level, implementation class level, there might be few differences between one class to another class that we'll discuss. But for now, I'm talking about the generalized features of all map classes. Okay. So first thing, if you want to store data in the form of a key and value case, then you should go for map. That's fine. Second thing, here keys should be unique. That is one thing. What is it here? Key should be unique. And values cannot be duplicated. Sorry, I'm sorry. It's opposite. Values can be duplicated. Are you following? So what is the point here? You cannot have duplicate keys, but you can have duplicate values. Okay, keys has to be unique. And if you try to insert duplicate keys, what happens is the new key replaces old key. Nothing happens, you don't get any error. But what happens? The new, whichever the new, that new will replace old. Got it right? So that's the point. So keys should be unique and values can be duplicated. Next one. And here, whatever you do on a map, it is done through keys. If you want to add something into a map, insert something into a map, if you want to update something in a map, or if you want to delete something in a map, or if you want to, what is that? Extract something from a map. You want to read something from a map. Maybe all these things you can do with the keys. And here keys are very important. They plays a very important role in a map. Okay. Like if you talk about list, how indexes are very important, or vector. If you talk about vector, how indexes plays a very important role. Similarly, in map, in case of map, keys are very important. You do anything on map, we do that with keys. Of course, values are important. I don't say values are not important. I'm not saying that. Point is, if you want to do anything, for that we need keys. Clear, right? Second thing. And again, a key without value is also useless. There is also one more important thing, because that makes no sense. It doesn't make sense, right? So you have only key with you, you don't have a lock. Then what is the use of that key, right? Similarly, same thing here. Okay. So second thing, insertion order is not preserved here. So insertion order is not preserved, except for maybe if you look at this list map, like list set. I have discussed this, except for list map, because list map uses internally a linked list as a data structure, as it is using the list and map together internally. So this insertion order is preserved in case of list map, whereas hash map and tree map don't preserve the insertion. Are you following, sir? Hash map and tree map don't preserve the insertion order, whereas list map will preserve the insertion order, because it is it has two data structures in that, a list plus map. You know the behavior of list preserves the insertion order. That feature of list is added to this list. Got it, right? So except insertion order is preserved, except for what? Except for list map. Okay. Next one. See, the data can be heterogeneous for all these data structures except tree map. That two keys, not for values. Okay. Here, keys are important. Okay. I'm talking about key data. So again, when you look at this hierarchy, you know, sorted map or tree map, this has this special feature. They will sort the data. They are used to sort data according to natural sorting. That is ascending order. In that case, what is that sort map or tree map? What is it? They don't allow heterogeneous data for keys, not for values. Values can be heterogeneous, but keys for sorted map and tree map should be homogeneous, because the data in this sorted map or tree map are sorted according to the keys. If that is the case, keys must be homogeneous. And if you try to heterogeneous, one thing you might get a compilation error. Or otherwise, if you do some forcible conversion and try to put it there, it leads to some class cast exception. That is also there. Got it, right? So, for except sorted map or tree map, remaining two maps, the data can be heterogeneous. Okay, both keys and values can be heterogeneous. But for sorted map and tree map, data has to be what? The keys has to be homogeneous. Values, it's your wish, sir. Okay, second thing. So both keys and values have to be can be heterogeneous, except for what, sir? Except for sorted map and tree map, of course. Or tree map. So what happens with this two? Here in both of these, you know, right? These entities, the keys must be unique. Values, keys must be homogeneous. Values can be heterogeneous. Okay, so that is the point here. Anyhow, I'll talk more on that when I come to that point. I'll pitch in the same point when we discuss sorted map and tree map. So dynamic, of course, when you say collection, the first thing you should always remember is it's dynamic. It's growable and shrinkable. We don't have any issue with that. That's why we choose collections. You know why? Because collections are growable and shrinkable, right? So that is one more advantage of collections. What else? So this is most probably these are the important things. But the point is, it doesn't use any indexing again. Here, whatever you do it based on keys. Okay, that is one thing. Second thing, it doesn't preserve insertion order. Third thing, keys must be unique, but values can be duplicated. Fourth thing, both keys and values can be heterogeneous, except for sorted map and tree map. Even insertion order is preserved for list map. For others, it's not preserved. Okay, that's also important thing. and finally it's dynamic. So these are the important observations. Now the point is, let's talk quickly about a few things about map, like how to add elements to a map, how to remove elements from a map. So we need to understand this stuff because I see even in our code also, I keep seeing that. Of course, all this will be there. If you ask me what data structures I see more means, generally in the project which we are doing, I see map more. Map is something which is more there. And also, of course, other stuff will be there. What else I'm seeing is maybe I didn't see set and also the listing. I didn't see the list as well, but other stuff is there. And map thing, I keep seeing it regularly. Okay, map is something which is highly used in our project in the current model which we are applying. Okay, so I see a lot of map operations. Everything they try to use, for everything they try to create maps. And in few cases, I think for initialization of data, they might try to use this list that is also there. Okay, in the beginning, if you want to add some that data, they prefer to use the list thing. Okay, likewise, when you look at the data structures, what I have seen in the code here right now, okay, everything will be there. I'm talking about on a large scale. So one is list I have seen in the project. Second thing, map is most of the time I see map because right, in a real time. So that key and value pairs is very important. So that's why map has a lot of importance in the projects. Okay, keep in mind. Even when you go to the Spark, you need to play a lot of times on this map thing. Okay, so that is important. Is it clear to all of you? Null is okay. In Java, we consider all that, but here it's okay. It's not like we don't need to take it as a serious thing. Okay, got it right. So anyhow, null insertion is possible for both keys and values. I didn't check this, of course, keys and values. However, we can insert null for one time if it is a key. For a key, how many times we can insert a null? Just only for how many times? One time. Is that clear, sir? So that is a quick update about this. Next one. Now let me start discussing about map. First thing, the map tract. Okay, let's do a quick examples. Few examples on this. I'm opening this one. Somebody is asking a question. Okay. So most of other methods like applying filter, applying map, applying reduce, that is again, the way we work with them is same. That doesn't change. We will do a workaround, of course. So this week, probably we'll try to close this collections thing. So this Saturday, we will plan a workaround on all these collections. Okay, because now we are at the map stuff. So probably we are at the, at the end of discussing this whole hierarchy, right? If you look at the hierarchy, just see the diagram here, right? Even once you are really comfortable with one hierarchy, it's almost same for others. As you can see, now we have seen all the methods. We have implemented methods from traversable, iterable, and we have completely discussed about set on Saturday, and we have completely discussed. Now we will finish completely discussing map hierarchy. Then when you look at this we have discussed sequence, index, and sequence, vector, and about string and arrays. That is also there. You have an idea about string and array. And then right, we have discussed this. Probably I told you, right, this miscellaneous we will finish it maybe tomorrow or the next session. So once if you are done this, then for mutable we see few things, because mutable is also similar to immutable. Only difference I told you, right? Mutable don't have change, and we cannot change mutable, but we can change this, right? Even we can modify sorry, I think I told opposite. We cannot modify immutable objects, and we can modify mutable objects, not at program level but at memory level. Okay, this is applicable at memory level. In program you can modify it, but that is not exactly modified. Every time you try to modify an immutable object, a new object is created in memory. I think I have explained this on in some session where Madhu has raised a question. Okay, like fine. Now let's start dealing with this. So first, let's create a simple map here. Even though map is a right, we are creating key value pairs here because right, sir. Uh, Reason is simple. Some ABC. Come on. And we now use this what do you call this arrow operator to differentiate between keys and values. Okay, we should use arrow here. Okay, that is the uh, breaking point between these two. Okay, dividing point otherwise. So two arrow mark some BBC. Okay, and three arrow mark okay, some BBC. And four arrow mark. I'm just taking up to four arrow. Okay, that's enough. Some DVC, something like this. Okay, close this. And this is a map. And sometime back, we have a brief interaction with map, while discussing that option topic, if you remember, still I remember. After that, even I didn't go and refer that topic, but still, while doing that option, I still remember we have used map to apply option. You remember, I told at the time, when we go to the map, again, we have a detailed discussion. So now we are going to talk about the map here. Clear? If you see this, what is this here now? You have key value base, and if you just print it like this, print enough, rest of this. This is how the map object is implemented. You can see a map and with data input in the form of key and value base, right? Is that clear for all of you now? So now what we have to do? Now we should just try to see like how to add a key value, how to remove from that. So it's so simple. If you say something like map dot, you can see here, sir. The most of the methods which we apply is known to us. Suppose if I want to add key and value pairs, then we can apply a plus operator here. And if you want to remove key value pairs, we can apply a minus operator. Okay. Then plus plus colon, right? That also you can try, right? That's for appending data. Again, same thing, adding data. Even plus plus is also adding a map to another map. Okay? We can also check this. We have tried this while in list. Maybe if you want, you can try here also. So that is also there. Next, and other things, right? Collect method we had discussion. You can try here on map. Usually, all these methods are directly applied on keys, and through keys you have to get values. That's how it works. Got it right, sir? So now after that, other stuff. The drop right, you can try all that. Filter, flat map, flattening, you can try it. Let me finish all these topics first, and on Saturday we will plan a working session. This time we will plan it little more time, so that we have an opportunity to work on more use cases. Okay. And keys iterator, it probably this iterator method will try to get all the keys. Okay. And you can see here now key set, it returns all the set of keys. Maybe if you want, we'll try few of these methods. These are something specific to map itself. These are not there in list or sequence or set. Okay, this keys method, key set, probably you should find values also, if I am not wrong. And then keys iterator means it returns an iterable object where you have a list of keys in that. Okay, last anyhow it returns again the last key value pair. And then there should be a get method also, if I am not wrong. If you pass key, it returns values. Get or else means so if value is there, it returns that. Otherwise, it returns some other default value. That is get or else, and group by all that stuff. That. And then also, I think like keys, we can have something like values method. Can you see there? If you want to get only all the values from the map, we apply values. Anyhow, we will test some of those methods now here, and we get some understanding. Okay, all those methods which were new in the map we will discuss, which already we had discussed. That I am going to skip for now. Maybe we will preserve it for working session. So okay, now what is it, sir? What do you have to do right now? First thing, adding a key value pair to a map, something like map equal to, so map plus, we keep doing this number of times. How can I add a key value pair here? Something like I'm adding like this, 5, something like this. Okay. Let me try to test it. So map to equal. You can see I'm just adding it as a tuple. Maybe we can also directly add it. Yeah, I'm seeing some error. So add it as a tuple. We will just print it and see how it's going to be added. This is adding a key value pair. You can add it. This is a tuple. I had discussed this. Okay. Now just test it. You can see there it's directly added to the map. It's not added as a tuple, but it's added directly. Can you see there? This is how we add one key value pair to a map, existing map. Likewise, if you want to remove key value pair from a map, you can simply say map minus, whichever you want to remove, you can say minus. So probably you don't need, I don't think you need value if you want to remove something. Probably you can directly say like this. So map to, of course, map to minus. Okay. Let me use the same here. And also another error is there are few. This is a mistake. I should use map 3. Okay, fine. Then I should remove it from map 2. Okay, still I'm seeing that. Minus. Okay, now you can see, sir. So everything is fixed now. What is it then? See, while removing data, you don't need to mention the key and value. While adding, we need key and values. But while removing something, a key value pair, if you just specify that key, if you just declare that key, okay, if you mention the key, that's enough for us. Got it right, sir? So let's run this and see whether this key value pair with 5 and is removed or not from map 2. Let's see that. Perfect. You can see there that is removed from that. You can see, and insert starter is not preserved here. You can see there. Okay. And maybe if you try to add duplicate keys one more time, see here, say something like 5, some 10 arrow mark, just for a change. I'm putting 10 there. I put something like okay, some SSS. I'm sorry. I told you for duplicate keys, right? You know, one is a duplicate key. Now what happens now? The new key replaces old key. Which is new key? SSS is something. This key value pair is the new key. One with SSS. So if you can observe carefully, let me run this. See there. In the output, you can see you don't find ABC, but you are finding what SSS. Why? Because when you have duplicate key value pairs, the new key always replaces old key. So that's why you have to be careful having duplicate keys, and you cannot have duplicate keys in a map. That is the nature of it. If you ask me, sir, if I want both, what should I do? There is a choice, of course. Still, you have there are different ways of doing that. You cannot be directly in the map. In a list, we can store that data in the form of tuples, and might be you can make it as a pairs in the form of tuples. That is also one way, right? An alternative to the map. Got it right? And that you can convert to map as well. But once you convert, again keys are removed. I'm just giving you a heads up for all of you. Okay? But is this fine for you now? Got clarity now? So these are important things. Sir. Maybe your data can be both homogeneous and heterogeneous. Suppose if you see here, I am taking my keys as what? String. Can you see that? Some of my keys are integers and some of my keys is string. This key is string. Means what? Keys are heterogeneous. Likewise, values can be heterogeneous. If you want, you can take values as a heterogeneous. Got it, right? But mostly, if you ask me a real use case, okay, usually most of the time, keys will be integers. Most of the time, I'm saying. Here and there, sometimes it might be little different. Most of the time, data might be string, or sometimes it will be decimal type of data. That might be, I mean, data in sense value. Values might be strings in most of the cases. In some cases, it might be other type of numeric data. But I'm talking about if it is a big data thing, because right, when you are doing analytics, most of our data comes in the form in data sets. And when a data is coming in data sets, what is the usually what would be the type in data sets? It will be a string type of data. You talk about JSON, you talk about CSV, you talk about DAT files, you talk about okay, fixed length files as well, because those were the files which we have used. Right? Sometimes you might be using other type files, but the point is, in most of the cases, data comes in the form of a string, and we convert that to this kind of collections. We try to load that data into collections. How collections are useful in Spark, I'm giving a heads up again. And while you are loading, usually the data will be stored as values, not as keys. And your keys will be most probably what, sir? It will be in numeric type. It's not a string. You get that? But I'm trying to tell most of the time, not no always. Okay. So that is an important thing you have to remember. That's why keys might be probably most of the time strings, and values can be most of the time integers, but they can be heterogeneous. But the concept of heterogeneous, again, what, sir? Not always recommended. Keep in mind. Next one. Next after that. So finally you got clarity, right? What is it? It is dynamic. It can have heterogeneous keys and heterogeneous values. Okay. Then also, what is that? Keys cannot be duplicated. Values can be duplicated. Suppose I can have SS for, you can see there, sir. Put SSS for how many times? Some two times. And this works. We don't have issue with value. You can see there still, you can find there SSS for two times here. Can you see there? But if you do the same for keys, it won't work. Correct? And also insertion order is not preserved. You can see clearly here when you look at this. In the second case, you can see there 5 is coming first. But actually it has to be, and also we can see is a right, an unordered map here in case of the second, even in case of third one also. Okay, when you look at first one, don't come to a conclusion. You have an ordered this thing map here. Always when you look at that insertion order, we cannot tell about this map or set. Okay, reason is simple. Internally they uses hash code for inserting the keys here. This keys uses hash code. These keys are stored according to the address. Got it right, sir? So that's about this. Next one. Adding we understood, removing we understood. Suppose I want to add a map to the directly another map to this. I want to merge one map to another map. Then how can I do so? It's so simple. Something like value, some map equal to some map plus okay. Then map of what I can do now. I can just take something like some like okay 100 arrow mark, some a comma again 200 arrow mark, some bbb. Enough, we don't need more, just an idea. Now what I'm trying to do, I'm trying to merge two maps, one map with another existing map, a new map with existing map. That's why plus plus can be used. Okay, so now I'm printing map 4 here. Let's see what happens. And whenever you are adding or whenever you are appending data here, you can see when you apply plus plus, always what is that? The point is we insert in the form of key value pairs. You can see there. If it is one key value pair, apply a tuple here. Otherwise, it leads to error, compilation error. And if you want to remove, then what you can do minus minus. If you want to remove a map from existing map, then what you have to do, you should do minus minus. So let's run this. And you can see there that data is added 100 and 200 stuff. But insertion order is not preserved. You can see that there. Correct. Now after that, if I want to remove some data from this, not 100 and 200, I want to remove 3 and 4, then how can I do that? You can say minus minus, and that has to be passed in the form of what, a map here. I should say something like 3, and also we have to say minus minus. Let me try like this. If it is going to work, it's fine. Something like 3 s's here, because right, while removing we don't need to pass key and value page, but I'm just testing. Then this is what's it, this is dbc, right? And print map 4. Still error is there, right? Because first thing, variable is duplicated. Okay, and now I think it looks good. When you remove, while you are trying to remove a map from existing one, means a part of a map, then you have to pass in the form of key and value page. But internally it uses keys only to remove the data, no doubt about that. Okay? Now you can see there what happened with map file. Yeah, that's perfect, right? You can see there 3 4. 1 2 3 4. Still 1 2 3 4 is there. Means what? Data is not removed. The 3 is there. But what data we have here? 1 2 3 4. Okay. When I do this, still 3 4 is there. Means what should I do now? I'll do one thing. This is not working, even though there is no compilation. Okay. Probably I'll do like this 3 minus 3 comma 4. Let me put it as a tuple and see. No, this is not working. Okay. Then let me just Google it directly. Minus. Let me see if this guy is giving any minus here, because I don't want to much of the time here. Those are sets actually. Maybe if anybody found that, just ping me, sir. Okay, I'll talk about. There is a question coming. We'll discuss that soon. Give me a minute. I'm just checking on minus pattern map. This is also a good site. Plus equal to is fine. We can do that. We're doing plus actually instead of plus equal. Okay, we can do minus equal. The tuple thing is also fine. Okay. Yeah, we should apply minus equal instead of directly minus. That is also one scenario. Plus is also still minus also can be applied. But I will check on how to deal with minus. So, but now for now, what you can do, minus equal to, you have to pass it as a tuple, like 3 comma. This should work, I hope. Yes, now I got the point. Reason is, right? Did anybody find out this? So this is the disadvantage of heterogeneous data. I am assuming both as integers, right? That's and but actually 4 is string. So if I am not wrong, then this should also should work. Then you can see here, I am taking this as what's a I'm taking this as an integer, but your key is actually a string. Now that's what you have to be. You have to be careful when your data is heterogeneous. I just missed that thing there, right? So I am a creator of that, but the creator itself forgot that. Okay, because every programmer still no changer. I didn't see anything. Then this is one identification. We have fixed it, but still no. Then finally I'll do one thing, sir. It's a minus equal. Then you have to take a tuple, some v comma and double quotes. Let's try this scenario. This is going to work for us. But this is applicable directly on and I should remove this as well. This is applying something on the existing one. Okay, I'll just analyze and talk to Mark. I don't want to waste much time. So probably when we are doing this, it's not working. Map minus equal to 3. That's what we have done. It's like, let me do one thing. And also this has to be var, right? That is the case. You cannot modify a val object. But still, okay, I will do work. I will do an analysis on this. The removing part, I will check it. Probably, if you want to remove one element, this is the process. Might be I forget one more thing. I have done all this. I'll do one thing, sir. Hope I am not boring you, right? If it is boring, I'll skip it and move to the next one, sir. So we didn't try it directly with minus. Maybe I want to take it as equal to. This is last try. If not, we will try it in the next session. Okay, I will like analyze and update in tomorrow's session. Some minus something map of. Let's try to pass minus 3 comma 4. Let's try to do this. Then println of 5. Let's run this. See, finally we got it. See, sir, succeeded. Am I able to remove both successfully? So means we can directly play with this instead of minus minus. You can choose minus and you can pass. If you have multiple multiple pairs to remove, just do it like this. So is that clear now? Hope you are clear with the workaround we have done and how. No, I have tried all the possibilities. Finally, one possibility is successful because that's how it happens in a real time. Nothing will come directly. It's a trial and error sometimes, right? So when you keep doing it will hit it somewhere. Is that clear for all of you? And somebody is asking a question. Let me answer that question as well. It's something Sunil. Insertion order is not preserved. So how the program print the latest value in case of duplicate keys? Oh. The program is not printing here, Sunil. It's the algorithm. Behind every data structure, there will be an algorithm. And when you keep adding elements, you can see latest key value pair is this one, not the first one. Means what? You made your decision. What your algorithm thinks these things is when you have a duplicate key again, it will try to use the latest one rather than the old one. And also, what happens again? This the hash code of the latest one is replaced with this one, because when you try to insert same element, probably it might try to use the same hash code, because if there is no duplicate, the same hash code is assigned for one, then it might get a conflict. Already your JVM thinks already there is a hash code for one, where this is coming from. Then it realizes this is a duplicate, then it will try to replace this duplicate hash code with the old hash code. Got it, Sunil? That's how the algorithm works. Sunil, I think it's your question. Hope it's clear now. Even you can also prepare an algorithm like that if you have interest. We can sit and write a code for that ourselves. Even I can write. I'm confident on that. Okay. If you wish, on Saturday you ask me the same thing you throw as a challenge. I will work on it. Now next one. Shall I switch to the next discussion? Would you like to test this first before I talk about other methods? Suppose I want only keys from that, sir. Something like val, right? If I want only keys, val some uh, keys. I'm just making it as keys itself, the name equal to then some map dot. You can apply on any kind of map dot. You can here, you can see there, you can have a couple of methods here. One is iterable. We don't need iterable. We can choose iterator or key set. So this doesn't take parentheses, so leave it like that. Then what do you do? Print of keys. Now what this gives us? It gives us exclusively only keys here. You can see that you got all the keys, but right, keys are written in the form of a set. Why it is writing this to a set? Because keys could not have duplicates. So not to take any chance, okay, it is trying to put it as set, so that usually map itself will filter that, and set is a best choice to store elements which doesn't allow duplicates. That's why it is using set. Suppose you see here, observe carefully how right people do coding. Now after that, you take values. Now you say to get values from a map, there is directly a method here. What is it? Just type one first letter, values itself. Now print values. Now what would be the return type? Guess the return type here. Is it? Do you think set will be here? If you are returning set, means the whole meaning of map concept is spoiled here. Why? We can have duplicate values. When you try to put it to a set, add it to a set without messy, it will remove all the duplicates. So that's why you try to run this. See there, observe the data structure. What does it use? Map like default values. Of course, it's coming with some data structure. Not list are returning, but it is using something of its own type. Got it there, right? And you can see still your duplicates are intact. SSS is coming for two times, right? Is that clear, sir? So these are something which is exclusive to map only, sir. You don't find this in set, or you don't find this in sequence. These methods you can see now, which are something very exclusive here. Okay. And also iterable I have discussed. If you want, you can try to apply that iterable as well here. That's up. So these are most used, and filter, map, all that stuff you can apply as usual. Maybe I told you, right, Saturday or Sunday we will plan one working session. Both or 2 days we'll plan working session, because that will be more interesting. Got it, right? So now what you do? I hope you are clear with the map thing, appending one element, appending, merging one map with existing map, and also removing one element and removing a part of a map with multiple, with right, more than one pair from a map, and then how to get only keys and how to get only values, and the kind of data structures these methods are returning, right? Still, what is this kind of data structure here? It is probably map is both mutable or immutable. It has both kind of things in that. Now, when I move to the again the hash map or list map, probably these concepts are same, which but there are few important observations that we should understand. That will end the discussion of map. Later on, we will quickly finish the discussion of mutable hierarchy as well, and then conclude the collections. If anything important, I'll bring back to your notice. So please test it, sir. Please test this example. I hope all of you are clear, right? Anybody has any questions? I think Sunil has an answer to his question, and likewise, if anybody has questions, you can ask me. I try to answer if I know. Otherwise, we'll see tomorrow. Please test it, sir. And from here, it will be more interesting, sir. When we start doing Spark, I believe Spark, you like Spark more. Madhu is already in love with Spark, actually, if I am not wrong. Madhu M, okay, Maruboyna, Bank of America. Please test it, sir. If you have questions, please throw the questions. So now successfully we are able to see how to remove, right, more than one key value pair, how to remove one pair. Likewise, we have seen other stuff you can apply. If not, we can try it on when on Sunday. Saturday we'll make it as a workaround session. And I see in our right the project this appending this key value pairs like this. I see number of times people doing that. Okay, using that tuple and adding to the map, right? And also like these things I have seen number of times actually. This is good to know. These scenarios like how to add, how to remove this stuff. Also iterators, they apply a lot of iterators, sir. That iterable stuff or iterator stuff people use a lot of times in the code. No, if it is a collection, iterator is something which people always try to use. Please confirm once it is done, sir. Okay. So I see, right. Sunil, I think you are following, right? You are coming little, right, after some of the sessions were missed. Still, you have everything there. You can upskill yourself. If you wish, if you can invite anyone, sir. If anybody is interested, you can still get them to the classes. We don't have a problem. Your friends, your colleagues. Any more questions? All right. Okay, sir. We will meet tomorrow. Tomorrow we will finish that remaining implementations. Got clarity, right, about the map stuff? Okay, we'll stop here. Huh? See you.